Hey, everybody. Welcome back to the You're Not Broken podcast. Super excited to have my friend, Dr. Louisa Nicola. I feel like we met on stage. I don't know. We don't even know where we met. And thank you for coming on the podcast.
Oh, no, thank you so much. I always admired you and loved you. And I think that the day that we met, I was really nervous. And now I can call you my friend, which is so cool.
See how quickly that happens?
I know, right?
When
Social
you're
media.
a good, smart person, you're like, sweet. No,
You
you're
get
one
it?
of the more well-connected people in the universe, Dr. Nicola.
Why do you say that?
You know everybody.
Yeah. I try to.
You generally love humans. You love science. You love conversation. It just makes you very easy to want to be friends with.
You know, I have a mission and you're part of that mission too. And I love that. And I love the human brain. And you have one of those, a really beautiful one. So
yeah, I want to keep it good. So that's what we're going to talk about today of like, how do we keep the brains braining in a good brain fashion? So tell me about your schooling and your, what's the doctorate in, why brains?
Yeah.
Catch us up to like, why brains?
So I first started off with exercise physiology and then moved into a master's of mathematics, believe it or not. I was quite the mathematician, and that's actually where I got my first real look at algorithms and neural networks. And so my thesis really looked at like neural networks and algorithms. I then fell in love with the human brain. I saw my first cadaver at the age of, I think I was around 20. And I got to actually see a human brain in flesh and obviously look at the coronal sections, fell madly in love with it. I often say the human brain is my first love. And then after the master's finished, I think I was still around 21, 22. I moved into a master of medicine. And that was at the University of Sydney Medical School, and then went on and did a doctorate in neurophysiology. So neurophysiology, for those of you who don't know, is a subspecialty of neurology. And I have spent the last decade working in neurosurgery. And basically, my main role in there is looking at two things. First of all, if we're going into a craniotomy or even a tumor resection or a spinal surgery, ensuring that during the surgery, the patient isn't paralyzed or stroking out. And you can imagine, a lot of people say, oh, doesn't the neurosurgeon know how to not do that? It's like, well, the brain is the most vascular rich organ in the entire body. And just, moving like a hairline away from where they're cutting or resecting could mean the difference between staying alive or complete paralysis, for example. And we now have, EMGs to help us guide us through that process. And it's a really, really amazing thing for patient outcomes.
I love that. I also love that you're correcting people when they're like, can't the surgeon just do it all at the same time?
Yeah,
it's like, no.
Yeah.
It takes a team in the operating room, people.
Yes. But also my main mission now is to end Alzheimer's disease. And this is because as a neurophysiologist, when I was working, I think it was around 2016, I was working in the neurology wing. My entire mission then, like I got tasked with, Louisa, you need to be doing all of the EEG scans to pick up on something called mild cognitive impairment. And I didn't really know what that was. And we'll go into it. It's a pre-dementia state. And I was just tasked with scanning all of these brains. I think I've done around 5,500, 6,000 brain scans since then. And I was picking up on early onset Alzheimer's disease, mild cognitive impairment. And every time I went to the attending and said, what does this mean? Why are we giving so many diagnoses of Alzheimer's disease? What can we do for these patients? His answer was nothing. We can't do anything. They're just born like this. And that didn't sit well with me, Kelly. So ever since 2016, I've gone deep on publishing, first authoring a number of academic papers to understand why is it that 70% of all Alzheimer's disease cases are female? Why is it that Alzheimer's disease and dementia is the number one cause of death in Australia and the UK amongst women? And why is it that 95% of all Alzheimer's disease cases, why is it that they could have been prevented? So that's what I do now.
5% can be prevented?
Correct, 95%. And that's actually something I would, caution that. I would say that it's around 98%, but there's only around 3% of all Alzheimer's disease cases that are 100% penetrant, that are
Yep.
driven
Yep.
through genes. The rest, 90, why do we have it? Because of lifestyle.
Mhm. And I mean, one might say the success of our lifespan. Meaning when we were dying at average age of 47 because of blunt force trauma and infections and dirty water and all the things mammals in the wild die of, we didn't have this longevity of like the resilience of the brain. We have a lot of neuroplasticity and a lot of resilience and a lot of backup plans built into the system. But because we're
Mm.
not dying of everything else and we are aging, I mean, is dementia and Alzheimer's and maybe neurodegenerative diseases in general a result of an extended lifespan? But it doesn't mean
It is.
it doesn't mean
Correct. And it's so funny because that's when we can bring in the sex differences in this disease. But you look at this disease, and yes, we are living longer because of antibiotics, penicillins, and vaccines, which have gotten us to the stage of the degenerative process of our brain, which is inevitable, by the way. The brain does age, but dementia is not part of the brain aging process.
whoa, that's crazy. I think, that it's see people doing this repeatedly, which I'm grateful for, is people keep being like, women aren't getting dementia because they live longer. Women only live on average 4 years longer than men. And dementia doesn't happen in the last 4 years of your life between the ages of 80 and 84.
No,
But I think
it's a
that's
disease of midlife.
yeah, and it's a big myth that it happens because women live longer. That argument falls apart so quickly. And I think the other thing, and I say this when I'm on stages of like on that horrible, horrible Tuesday that you or a loved one gets diagnosed with dementia, it started happening 20 years ago. And that's very hard for people to get their head around because everybody thinks it's the day of the diagnosis. Now I have dementia. And it's not black and white. The diagnosis got on the chart that day, and now you think differently about things because of that. But it started happening 20 years ago, which means we've got a lot of lag time. And when we look at prevention, we have to go back. We have to talk about midlife 40s, 50s.
Yeah, and this is the question that is on my mind, constantly. And I get asked a lot, why do you focus on dementia? You're young. Why don't you focus on something more exciting, like,
Why can't it be sexier?
IVs and why can't it be sexier? I'm like, but it is sexy because it does happen in your 30s. I'm in my 30s and I'm trying to prevent all cause dementia and Alzheimer's disease now. And not because I've got an increased risk, which we'll go over, but I am, as a woman, I do have an increased risk, but because I know the prevalence of it. And if you don't take care of your brain now, there is no reversal. I know that there are some physicians out there claiming that they've reversed Alzheimer's disease, and transparently saying that, in my opinion, there's no reversal, there is no cure. And getting the diagnosis of Alzheimer's disease or all-cause dementia, we have to figure out what the difference is between those two. It's comparable to end-stage cancer. When you are diagnosed on that horrible day, hopefully nobody will be, but of pancreatic cancer, for example. We know that it didn't happen just then, but we know that it's very hard to come back from that. Would you agree?
Yes.
Exactly. So why didn't we pick up on it at stage one? Well, it's very hard to. It's very hard. We don't have the imaging right now to pick up on stage one pancreatic cancer. But when we pick up on it in stage four, there's generally a very short time course, of how long you'll live after that. And it's the same as dementia. And people think that all cause dementia or Alzheimer's disease is just, oh, you forget your memories. No, it's so much more than that. And there is no coming back from it.
Can you break it down for people? The difference when we say Alzheimer's versus when we say dementia, what specifically about that disease makes it Alzheimer's? And Alzheimer's was a physician who first described it, but what would you say when because people lump dementia and Alzheimer's into one thing? Can you just give us the 101 on that?
Yeah. Quite simply, dementia is just the umbrella term that's used to describe the decline in our cognitive functions. Cognitive functions are thinking, processing speed, visual acuity. These tend to decline as we get older anyway, especially processing speed, like speed of our thought, etc. That's just the umbrella term. But Alzheimer's, it's actually Alzheimer's dementia, is the most prominent type of dementia. 70% of all cases of dementia are Alzheimer's disease. And we've got Parkinson's dementia. We've got dementia with Lewy bodies. We've got many different types of dementia, vascular dementia, which comes second after Alzheimer's. But Alzheimer's is very different in the sense that upon pathology, if you look at this on neuroimaging studies, we'll see the buildup of two proteins. And we've got the amyloid beta protein, and then we've got the tau protein. And these two are distinct features of this disease. And, there's something called mixed dementia because you can see some vasculopathy as well. So it kind of crosses over with vascular dementia as well in some cases.
And people, I think for the longest time, thought that the tau proteins and the beta amyloid were the problem. Therefore, the billions of dollars were spent trying to figure out how to clear the brain of these proteins. And that's changing. There was an investigative journalist who published a book called Doctored, talking about some research fraud, but also just the amount of money at the end stage, right? Being like, how can we get the tau out and the beta amyloid out and attack those proteins? And now, correct me if I'm wrong, but the theory is more that those are signals or waste products or landmarks, but they themselves are not the problem. And also, people can have those things and not have dementia.
Yeah, and so you're completely right. So Alzheimer's used to be the amyloid cascade hypothesis, where we saw this cascade of amyloid in the brain, and so we just thought that this was what's causing Alzheimer's disease. So then the FDA went and approved, Leqembi, aducanumab, all of these drugs, which is the controversial one you just mentioned, to go out and clear the brain of amyloid. And it turns out that even after clearing the brain of amyloid, cognitive performance didn't subside. Like people were still had Alzheimer's disease. So we're now moving into more of an era where we know that amyloid beta is not the villain. Amyloid beta is an antimicrobial peptide. It is actually a protective peptide, is just, if you will, a breakdown of a protein. It is actually needed in the brain to protect us. Okay. Then we've got tau protein, and that actually lives in the axon of the actual brain cell. So what happens is, let me just, for your audience, if you can imagine like a tree, for example, inside the actual cell body of the neuron, we've got around 87 billion neurons, which each make around 5 to 10,000 connections. What happens is when we feel stressed or when we actually have a virus, think the chickenpox, think shingles, any type of virus, your brain is surveilling that. It's under constant surveillance because it wants to do two things: survive and reproduce. So anything that attacks those two things, it says, okay, we need to protect ourselves. So the neuron cell body itself starts to push out amyloid. Amyloid is an antimicrobial peptide. So it goes out into the cerebral spinal fluid and basically helps trap pathogens, if you will. It helps you against these, a cytokine storm. It's, in the case that you have activated your innate immune system, you've been stressed, your immune system is down, we release amyloid, and it goes out there to shield the brain. Now, just stay on that for a moment because it stays out in the cerebral spinal fluid and it kind of interferes with the connections. I said we've got around 5 to 10,000 connections per cell. The amyloid sits out there in the middle of those connections. Okay, so we've got this sticky protein just getting in the way of those connections. Those connections, if we don't have a good connection between two neurons, then we see slower thinking, brain fog. I'm not feeling too good because the connections are not connecting. Now, tau protein is actually quite remarkable. It sits in there. It stabilizes the microtubules, the railway tracks inside the axon. Okay, it's there. And if that becomes hyperphosphorylated under stressful conditions, what happens is it actually breaks off of the microtubules. It stays in the axon, but it starts to form these tangles. Okay, just, not indifferent to the amyloid plaques, it starts to form these tangles within the axon. And then what happens then, you get the collapse of these microtubules and then the collapse of the entire neuron itself.
Good Lord. Compensatory mechanisms to a response that the body's sensing. Too much can lead to pathologic outcomes or kind of less proper functioning of the neurons themselves.
Yeah, less proper functioning. And what we see eventually is, okay, let's just say we are still under attack, we're still under stress, and your brain has released, your neurons have released all of this amyloid, and it's sitting there in the cerebral spinal fluid. It's sticky. So then it interferes with the axons, it interferes with the connections, and then dementia and Alzheimer's disease is a network insufficiency. Your network is breaking down. So we've gone from having a cell that has 5 to 10,000 connections to maybe a cell that has 2,000 connections. Now you imagine that 2,000 times 87 billion is a smaller number than 10,000 times 87 billion. So the network, we have a network insufficiency. Your brain is like, okay, I'm going to take the seat. It starts to come down like this. And that's why on neuroimaging studies, we see more space between the skull, if you will, and the brain. We see it because the brain is decompacting and getting smaller. So atrophy of the brain.
White matter hypointensities.
Lesions. Yeah,
lesions?
white matter hyperintensities. Yeah. And these white matter lesions are occurring due to the breakdown of the axon itself because of the phosphorylated tau.
I think people want, especially on social media, people want things to be black and white. They want things to be yes or no. And there are so many things that impact brain health. And then what people will do is they'll be like, my mom smoked and drank and never got dementia. Or my mom didn't do any of that and still got dementia. And I really want to emphasize to people the multifactorial, because again, the brain's pretty resilient. It can take some hits. It just can't take hit after hit after hit. But even some people who hit it really hard don't get dementia. Because I think people will use that as a way to dismiss science then. Because they'll be like, what do you know? My mom never exercised and didn't get dementia. They use this N of 1 to dismiss science, but that's not how science works. Science doesn't work by N of 1. Science works by testing hypothesis and repeatable patterns and looking at big things and big data sets. Can you kind of speak to that on helping people understand the complexity of this?
Everybody is individualized. And I love how you said the N of 1. Okay. But in the reverse, right, we can have multiple studies on millions of people, and yet you still have an N of 1 where all of those data sets actually doesn't work for this N of 1 patient. And I've seen that, and you've seen it too. And so it's so funny that people do choose the divide, N of 1 here, and so I find that really interesting. But when it comes to, my grandmother was drinking and she lived to 100 and she did this, that's great. Everyone is, this disease is very in favor of what sex are you? Are you male or female? And I mean, at birth, do you have ovaries in a uterus? And that's the first thing. And then the second thing is, do you have the genetic mutations that involve this disease or the genetic risk factors that involve this disease? Because the data is so strong that women are disproportionately more affected by the ApoE4 gene than men. They are actually at an increased risk, at a doubled increased risk than men. We can go into that, but I want to actually bring up one thing that you mentioned. You can have at the end of your life a head full of amyloid, but still have your cognitive functions preserved. Why is that? That's because of this theory called cognitive reserve. And it's phenomenal, meaning that if you can have a strong performing brain, your neural connections are so strong that it can withstand the pathology of amyloid. Very rare, but I do like that hypothesis as well.
I love it. I think that, the gene theory, the discovery of the human genome, all huge advances. I remember where I was sitting on a couch watching the television when they said we've now mapped out the human genome. And we're not going to have any more diseases anymore because we'll just figure out the faulty gene and then we'll just find a drug to swap out that gene. And I remember where I was sitting when this happened. And I think what it's done is it's given people the permission to sit on their butt and be like, well, I've got the genes. So, and what people don't understand is genes are not destiny. Like what you were talking about earlier is how your behaviors and your health can turn on and turn off genes and compensate for them. So I want to talk about the APOE4 gene. And when you said 98% of dementia is preventable, what would you say to the people who have that gene?
Yeah. So when I say 100% penetrant, meaning for example, if you've got a genetic mutation on chromosome 4, you're going to get Huntington's disease. This is something you're born with and we can't right now do anything about it. However, there's 3 genes involved in what we call early onset Alzheimer's disease, early onset dementia. That is amyloid precursor protein, presenilin 1, presenilin 2. If you do have a mutation in one of these genes, you will get this disease, right? They generally happen in frontotemporal dementia like Bruce Willis or dementia with Lewy bodies, etc. Then they are mutation, genetic mistakes, if you will. Then we've got risk factor genes, whereas if you have these genes, it just raises your risk of getting the disease. And the strongest risk factor for Alzheimer's disease is the apolipoprotein E gene. And they come in 3 variants. You've got E2, E3, and you get 2 copies, one from mom, one from dad. I've gotten tested. I'm an ApoE3. So ApoE2, if you've got this gene variant, you're very lucky. I'm envious because it seems to be protective against the disease and vascular damage. If you've got ApoE3, it doesn't raise your risk and it also doesn't help you. It's not protective. So you're part of the average, and around 70% of the population is ApoE3. Then you've got ApoE4. And that is the one that is responsible for increasing your risk of dementia, because apolipoprotein E helps with lipid metabolism in the brain. It helps transport cholesterol and fatty acids through the brain. So if it's dysfunctional, then what can we get? You can get what I call atherosclerosis of the brain, the buildup of plaque in your brain. And that's not good, because that can lead to stroke and obviously the downregulation of your blood vessels working. Here's what I want to point out. Around 20% of the population is heterozygous, meaning 1 copy of ApoE4. 1 copy. If you do have the ApoE4 gene, just 1 copy, if you're an E3, E4, if you are a male, it raises your risk by getting the disease by 2-fold. If you are a female, it raises your risk by 4-fold. How unfair is that? Okay? Just by being female. And around 2 to 3% of the population is homozygous, meaning they have 2 copies of ApoE4, and that raises your risk, if you are a male, by 10-fold, and if you are a female, by up to 15-fold of getting the disease.
Okay, but it's not destiny.
Again,
like don't throw in the towel, people. Like, and again, it's pretty rare to be homozygous, but even people who are homozygous don't always develop dementia.
Here's an interesting study, and this was a landmark study done in Nigeria, which showed that they have the prevalence of the ApoE4 gene is the highest, and they've got the lowest population of Alzheimer's disease cases. Why is that? If people are walking around in Nigeria with an E4 carriers, but they don't get Alzheimer's disease, then we know that this is a disease of epigenetics.
I love that. Let's talk about brain metabolism and hormones. First of all, I hate that we call these sex hormones. I think they should be called neuroendocrine hormones, but they're made in gonads. So I'm talking about estradiol and testosterone. And we're looking, Lisa Mosconi, all the brain people are looking at what happens 20 years before that awful Tuesday that affects the pathway of dementia in people. And what happens is outliving our ovarian hormones. Layman's term for that is menopause, but that has to do with periods, and we're talking about outliving hormone levels. But people don't understand that our brain has testosterone and estrogen, and testosterone and estrogen help the brain metabolism. Specifically, testosterone helps glial cells, which are the support people for the marathon of the neurons. It helps myelin sheaths, and estrogen and testosterone help mitochondria. And what I'm doing is I'm building our thesis here. So take over, say what you would like to say about hormones and the brain.
I've got 2 things to say. First of all, your brain cells, the primary fuel source for the brain is glucose. We need it. The brain takes 20% of the total calories that you ingest. So it's a hungry organ. It takes a lot of brain fuel. So when this becomes dysfunctional, which we've seen this in neuroimaging studies with Lisa Mosconi, that during that perimenopause stage, due to the drop in estrogen, we have a reduction in brain glucose metabolism, meaning that your brain just can't uptake glucose into the neuron efficiently. Our brain fuel is reduced by around 20%. And what I think is really interesting as well is that we know, and I've sent you one of the studies on this, we know that estrogen actually supports tau in the microtubules. And I don't know if you looked deep into this study, but it was actually pretty fascinating, because this was the first study to show that estrogen blocks an enzyme. And I believe the enzyme is GSK9-3 beta. I believe that's correct. That's an enzyme that actually phosphorylates tau. So if estrogen blocks it, protecting the axon, then that's wonderful. We can have an intact microtubules. We can have an intact axon. Therefore, we can preserve our brain microtubules. But in the event that we don't have any estrogen anymore, then we're at an even increased attack because the tau can become hyperphosphorylated. So hormones, these neuroendocrine hormones, are so incredibly important for ApoE4 carriers, but for females in general.
Yeah. I mean, we have data in men specifically that men with the lowest amount of testosterone have higher risk of depression and dementia. So we have that. We have Lisa Mosconi's amazing meta-analysis looking at all available studies. If you start hormones young, again, you have to get on this before enough insult happens, right? Hormones do a better job of preserving function than repairing function. I really want people to understand that. So if there is a prevention of dementia, it is young, right? Like young menopause, so 40s, etc., or at least young meaning 10 years hasn't happened yet. We haven't had the brain undergo those metabolic changes where they're experiencing hits that eventually add up to dementia.
Yeah, correct. And I think, we focus so much, which you would notice, we focus so much on the Women's Health Initiative, which showed that intervening with hormones at 65 years and above, synthetic hormones, raise your risk of getting dementia. And this comes down to the density, the estrogen receptor density, right? And we know this obviously from Roberta Brinton's work as well. And so we now have even more evidence to show that intervening with hormone replacement therapy during the perimenopause stage, during that window of opportunity, is actually going to be better for brain health outcomes due to receptor density.
And I want to pick on, right, so you have less receptors when you're older.
You have less receptors, yes. And
because they've down-regulated. But right in the perimenopause, early menopause, your brain upregulates receptors, basically looking for any available hormone. And then it's like, okay, well, they're not giving me any hormones. I'll down-regulate. And that's Mosconi's functional MRI image of the receptors actually going up in early menopause.
Yes. That is correct. And the more, and that's what they showed with the Women's Health Initiative too. And they also use synthetic hormones. I'm not going to even go into the WHI because I know you've done it so many times, but the synthetic hormones is not as beneficial, obviously, as bioidentical hormones.
Well, let's pick, I want to pick on it a little bit more because what the WHI did in their diagnosis of dementia was self-reported or family reported. So these weren't actual physician diagnosis of dementia. And in addition, there was no increased death from dementia. And like you said, if you have dementia and dementia is severe, that's what's usually going to get you. So there was no increased risk of death. And I think that's still being used against women in the 70-year-old plus who want to try hormones for symptoms or bone health and are being told it's going to make dementia worse. Is like, even with the oral synthetics, we don't have strong data to say that.
Yeah. And my standpoint is this, and I think that, you have to be Switzerland right now, especially as a brain scientist, because we don't really have the RCTs, which I know that they're on their way. But what I can definitely say is this for anybody who is, sitting in that, that they're a bit confused about the data. What I can say is anything at this stage that is going to help you and be a supporter to you, to do the things that actually do matter to reduce your risk of dementia, would you do that thing? The answer is most likely yes, especially if you know that this is the only disease that robs you of who you are. This is the only disease that robs you of your brain. You go to sleep with your brain every night. Isn't the whole point of life to know thyself? To know thyself, to have it be ripped away from you? Because let me tell you, I've seen, and it's very devastating. I work with patients who have this disease or who are on their way to getting this disease. They're in that pre-dementia state. And when they walk in and they go over a 2-year period from saying, "Hi, Louisa," to, "Are you my daughter?" it becomes personal because it becomes scary, especially if they've got 3 kids, a husband, a grandchild. It does become very personal. So I am here saying that if estrogen is going to support this woman from not having a hot flash at night to having better sleep or being able to just get up and go to the gym, then yes, I think that we have a pretty good understanding that they should be on hormone replacement therapy.
Yeah. And the data is the strongest in the ApoE4 people where
going
hormones are
forward.
probably
Oh, yeah.
even more protective or of added benefit in that more rare population than the general population. But I think that also helps speak to this. And I think when the internet breaks itself over this, number one, people always are like, well, observational doesn't matter and blah, blah, blah. It's like, it's helpful to know the randomized controlled trials are coming looking at prevention because I didn't know that that's happening.
Yeah,
Do
it's
you
happening. I
know
mean, look,
it's happening? Okay.
l
Who's do you know who's
yeah,
doing that?
I
Where's that?
think I think it's coming with the CARE, Lisa Mosconi's group
Okay, wonderful.
eventually.
Because that's gonna add a lot of validity. And I think the other reason is social media doesn't understand how hormones actually work. Like, once you have a deep understanding of how hormones actually work, you're like, "We have a biophysiologic basis to this theory." In addition, and I always think about this from, like, a public health standpoint. What do you need for a med that people are gonna take for prevention? It needs to be cheap, it needs to not have a lot of side effects, and it needs to prevent something that's relatively common so that you're not just giving a bunch of people something that they're never gonna get in the first place, right? And you're like,
Mm.
hormones, when you look at kind of the public health of what a preventative medicine might look like, hormones check those boxes. We know it
So
works
then
with
where's the controversy coming from?
where's the controversy coming from? That is exactly right. And I think you can pick it apart with so many things, mostly by explaining to people, because if you call these sex hormones, you have no idea they work in the brain, right? Until you're like glial cells, tau proteins, myelin sheaths. I love Brinton's data. Brinton's data looked at I believe it was the Humana database. Women who are on hormones had less risk of all neurologic diagnoses looked at, and this included Parkinson's, multiple sclerosis, Lou Gehrig's disease, in all
ALS.
comers, yeah, all comers dementia, all comers
Well,
meaning dementia.
what I
But
think
it's like,
is
how much more data do people need? They're waiting for this randomized placebo controlled trial, but I'm like, we have everything else.
yeah, the benefits obviously far outweigh the risk. What I think is, um, really interesting about all of this is that we have 80% of all autoimmune diseases are female. Now, if you actually look at the pathophysiology of these neurodegenerative diseases, and we can take MS as well, for example. I use EMGs and we use nerve conduction studies, to pick up, and we also use MRIs to pick up on MS disease, right? And what you can see is on an EMG, I will see something called slowing of conduction speed or complete conduction block, which travels along that axon. And so you can actually see the demyelination of this disease, right? Demyelination. Where else does demyelination occur? Well, Dr. Roberta Brinton, which you and I have spoken about, showed that during this stage where women have a reduced 20%, okay, of brain glucose metabolism, your brain, as I said, is there for survival. Your brain cells are not going to sit there and go dormant, right? They're not going to sit there and just die. They're going to do whatever they can to survive. So how do they do that? They need adequate fuel. Where do they get this fuel from? Well, they're really smart. Okay, these little neuron cell bodies, they're really smart for survival. They start to break down and what we call catabolize the white matter tracks, which is the myelin sheath, because the myelin sheath consists of a certain cell type, which is oligodendrocytes. They're fatty. These are fatty fuels. So then it
And
uses
fat's a
that
food
fuel
source.
source. Yes. And so they use that to bring in energy into the glucose and use that as energy, right? So there's so many things at play here.
Yeah, and I think, again, people's lack of understanding of how the body actually works hurts them.
Or how the
w-
brain works.
or how the brain works, because it's
Yeah.
like, well, muscles will break down for food sources. The bone breaks. We take bone for food sources. Like, we use the brain and the fatty acids for food sources if needed. If needed. And
Well,
so
this is
then
what
you
happens when
say,
we actually produce ketones.
yep. Yep, that's where they come from. And I don't want anybody to think that we're forgetting lifting weights, exercise, not drinking, not smoking, controlling blood glucose, not eating too much sugar. Like, all of this plays into brain health. But I think, given your expertise and my expertise on hormones, we really want to explain hormones to people.
Yeah. And can I just say quite transparently, one of my first ever systematic reviews was actually on resistance training and mild cognitive impairment. Now, I'll be damned if somebody tells me that there is a better intervention for delaying the onset of these neurodegenerative diseases than resistance training.
Yes.
Where we go with hormones is hormones can help you, support you to lift heavier, to motivate you to get to the gym. We've also completely misunderstood certain molecules like dopamine. You mentioned earlier that testosterone is a motivation hormone. Then we think about, everyone thinks that we've denoted what dopamine is. It's a movement molecule. Yes, responsible for reward. Yes, responsible for motivation and drive. But hello, what is Parkinson's disease? So there's a lot of unknowns happening in the
Yeah.
social media sphere.
Yeah, no, I think, social media builds on people's fear. It builds on people's current lack of understanding of how the body works. It builds upon people's desire for a magic bullet that fixes everything. Right. And so there's so many things. That's why I love podcasts so much, because it's like you actually can get into it and explain your stance. Because when I ask a question on a clip on social media and I say, does the brain eat itself? Which is the layperson's term for breaking things down, or catabolism, the opposite of anabolism. And the body does both. It builds and it tears down. That's how living organisms work. The internet literally poops its pants because it can't handle that question.
Because it's confronting, right? We just got stuck on, I won't take up too much of people's time, but I do want to say that there is hope, because I mentioned to you earlier, you've got this head full of amyloid when the brain is trying to protect itself. Well, guess what, guys? The brain's really smart. During deep, slow wave sleep, what happens? The glial cells actually shrink. And this is an evolutionary process. So your cerebral spinal fluid can wash out through the brain and exit the brain, and taking with it all of the debris and all of the amyloid beta.
The self-cleaning oven phase of your day.
Yes, like the washing machine.
What's that called? It's called something when the brain washes itself. Is it not? Is there not a word for that? I forget.
Lymphatic system.
Yeah.
Yeah. Well, yes, it's just like the lymphatic system in the brain, but glymph comes from the glial cells actually shrinking and exiting all of that. But here's the thing: what is the number one vasomotor symptom for menopausal women?
Hot flashes and night sweats.
There you go. So, what is keeping us from deep sleep?
Hot flashes and night sweats.
Hot flashes. There we go. So, ergo, the supporter hormone, estrogen, progesterone, if we have this available to us, maybe we don't get night sweats. Maybe we don't get hot flashes. And then maybe we sleep through the night. Just one night of sleep deprivation can raise your circulating amyloid beta levels. Just one night of sleep deprivation.
Yeah. As a surgeon who went through surgeon training, that's frightening. I believe in the repair and having babies. The body's ability to repair itself when given proper care is my the way I sleep at night, because I'm like, Lord knows the brain took some hits in the 20s and early 30s.
And if you don't sleep at night, you're less likely to get up in the morning and go to the gym and lift heavy.
You're more likely to eat sugar.
Yeah, leptin, ghrelin are all out of place. And we forget that lifting heavy, guys, is not just about aesthetics. You don't lift with your bicep, you lift with your brain. So yeah, you lift with your brain, and you're not just doing that, you're also supporting something called cerebral angiogenesis. So you're actually growing new blood vessels on the outside, not on the outside, but on the cortex of the brain, which is feeding your brain cells with nutrients and oxygen.
Blood flow. I mean, that's what's so interesting about the Viagra and the PDE5 inhibitors is it looks like, and again, there's no randomized placebo-controlled trial on this, but it looks as if people who take that, which one would argue they have a higher risk of cardiovascular disease, and that's why they're taking these medications, which is a dementia risk factor, but they actually have less risk of dementia. Why? It's a blood flow drug. Very, very interesting. In our time left, I want to talk about two things. Number one, there is more and more data looking at the prevention of dementia in people who've had shingles vaccines as adults. How does this vaccine seem to protect the brain?
Yeah, and this is huge. And for some reason, God knows why, it's a controversial topic. I think it's because it overlaps with the COVID vaccine. So I want everyone to know that this is not about vaccines as a whole. So when we get chicken pox as a kid, by the way, I've never had it. I had to ask my mom. She's like, I don't think you did.
I had raging chicken pox.
I never had it, according to
raging.
my mother,
Moms
who
know.
also doesn't know her age of menopause, which is interesting. So I'm like, you're not helping me at all. So when we get chickenpox actually stays in the system and it lies dormant in the dorsal root ganglia of the spinal cord. We don't need to go into what that is, but it lies dormant, asleep in the spinal cord. And the reactivation of that, so when these little pathogens wake up, when this virus wakes up under times of stress and low immunity, it reactivates and it comes back, but not as chickenpox, as shingles. And people think that shingles it follows the dermatome of the nerve root, but people think that shingles is just this awful, painful rash. But what it's also doing, hey, think spinal cord. What happens when it's in the spinal cord? Well, it goes up and it goes into the brain. It's already in the central nervous system. And in the brain, it causes neural inflammation and it causes the breakdown of our neurons. So shingles is increasing our risk of getting dementia. Now, we've got 3 beautiful studies, really well done natural experiments, both in Wales and in Australia, that showed that just getting the shingles vaccine over the age of 50 can decrease your risk of all-cause dementia and Alzheimer's disease by up to 30%.
Good
and
Lord.
It was more in favor of females.
Neuroinflammation is bad. Preventing neuroinflammation is protect.
Correct.
I love it.
And yeah, I made my parents have had the shingles vaccine more than once. And it seems to be more protective if you're over the age of 50. And that's because where do we get the most stress? Yeah.
A hit at a certain age is more of an insult than a hit when you're 21 years old. I'm using very sport analogies right now.
Yeah. And so again, would you do whatever you could if your mother stopped remembering your name? Would you do anything you could have done to prevent that?
Well, we got to talk about that for a hot second because people don't know. I posted this on Instagram a while ago. There are 2 randomized placebo-controlled trials, and these are old studies because we studied hormones before the WHI. So it's old studies. And it was placebo patch versus estradiol patch in women with mild cognitive dysfunction. Or early, it wasn't really, really bad dementia,
MCI,
but it was
probably.
it was early. They had a diagnosis, shit was going down. And there were, I think, 6-month studies. And the women on the estrogen patches had cognitive improvements compared to placebo, which did not. Now,
and why would that be?
This didn't cure things, right? But it made things better. Dare I say, slow the progression. Right. And so when people look and they're like, oh, all is lost, is as much as you can have your loved one exercise, as much as you can decrease insults like alcohol, as much as you can have them have regular sleep patterns. And there are 2 studies looking at this. And what's so embarrassing about all of it is here we are trying to prevent dementia or cure it when we have it. And we've thrown billions of dollars at the amyloid hypothesis and gone nowhere with those medications. And we've got 2 small studies with significant signals, and we don't even know they exist. That is an embarrassment to natural hormones and trying to help again, not a rare disease, people. Incredibly common. It's an embarrassment.
160 million people worldwide will have this disease by the year 2050.
Yeah. If only that they got better because they're probably sleeping better. Right? But I just want people to know these papers exist and admonish the research world of why aren't we looking more into this? Because prevention is fantastic, but some people already have the diagnosis and they want to know what can we do. And wrapping up, let's talk about creatine and why you like creatine.
So creatine is the most widely studied supplement in the world and arguably the safest. And we naturally produce creatine every day, but we're only really producing around 2 to 3 grams of it. So we have to supplement with it. Why? Because it helps with cell energy metabolism, something that is depleted in females and males. The reason why I love it so much, we've just had a pilot study on patients with clinically diagnosed Alzheimer's disease, where they were supplementing with 20 grams of creatine per day over an 8-week period, which improved their cognitive functions. And when you actually look at this study and think, how is that even possible? That is because the widely studied notion of taking 5 grams of creatine per day, we know now that just saturates the muscle. Your muscle takes 5 grams of creatine, you've saturated the muscle. So now we have to have excess creatine outside of that so it can cross the blood-brain barrier, get into the brain, and help the brain work better. So I love creatine because it actually works best in the background of stress. So if you've been sleep deprived, take 10 grams of creatine and you'll feel better. If you want to go to the gym, you want to lift harder, perform better, take creatine. We used to think it was 5 grams a day, but now to get the brain boosting benefits of it, you want to take around 10 to 15 grams a day. And I will add this, and I'll send this to you. A study just came out in the last 2 weeks that showed creatine's anti-cancer effects.
Stop it.
Yeah, I'll send it to you. And it was phenomenal. Yeah. So I'm about to break the internet with that one.
And get your creatine from a reputable source, because the creatine gummies on Amazon don't always have creatine in them.
No. And there is differences in manufacturing of the creatine.
All right, my love. Thank you for coming. Everybody check her out.
Thank
Her
you for having
Instagram's
me.
phenomenal. Her podcast is phenomenal. And she's also a phenomenal friend. So I'm feeling pretty happy over here.
Me too. Thank you, Dr. Kelly Casperson. You are my mentor, and I learned so much from you, and I'm so happy that you exist in the world. And I'm so happy that Jane Fonda fell in love with your hair just as much as I did.
Well, hold on. Okay, we'll wrap up with sharing this one thing because it's not on the social medias yet. I was on a panel with Jane Fonda in LA, and she said that my hair looks like it's having an orgasm.
Which I think is I didn't even think about that. How did she think about it? And she's 88.
I never thought about it. That woman's got a brain, and she exercises.
Yes.
All right. God bless. Well, hopefully that conference will give me that clip, because
that's amazing.
Everybody knows how amazing Jane Fonda is, and now I'm like,
yeah.
Wait, there's more.
Yeah.
All right. Much love.
Thank you for
helping.
Thanks
for helping all ladies. Bye bye.